Okay, so good morning, students. Myself, Dr. Pooja Yadav, and we are taking Sem 5 Electronics Communication Systems paper, and here we have started from what is communication system, and in the last lecture we have seen that what is amplitude modulation. Okay, you all must be remembering what is amplitude modulation. It is very clear to you how the amplitude modulation is done. And in today's topic we are going to study what is frequency modulation. Okay, we have studied types of modulations as amplitude modulation, frequency modulation, and phase modulation. So we were on the stage of seeing one by one modulation technique. So we have already seen amplitude modulation, and in today's class we are going to see what is frequency modulation. So you all must be remembering the definition of what is modulation. Okay, so is it clear to you? Modulation is clear to you. So the second type of modulation which we can do is frequency modulation. Okay, so this comes under angle modulation. Just a moment. Okay, so in angle modulation we have two types. We have frequency modulation and second is phase modulation. So in today's class we are going to see frequency modulation in details. So what is frequency modulation? Here we are going to see what is frequency modulation. See, whenever we are transmitting something, some data, some voice data, some videos data, or voice plus video data, so we'll have to first modulate that data with our carrier signal. Okay, so as to transmit it to a particular station or to a particular receiver place. So what we will do, we'll do modulation. So how we modulate the signal? We mix our signal with the carrier frequency, with the very high carrier frequency, and then we transmit the signal to in the air. Okay, so how we frequency modulate the signal is we modulate the frequency, means we vary the frequency of the carrier signal according to the modulating signal, means according to the input amplitudes we will modulate the frequency of carrier signal. Okay, so is it clear to you what is frequency modulation? One more time I'm telling to you, just remember the words. What is carrier, what is modulating, and what is modulated signal? These three terms are involved in the frequency modulation. Okay, so a very high frequency carrier signal is there. Our input signal is there, which we call as the modulating signal, and the resultant FM modulated signal is called as the output signal, which has to be transmitted. Okay, so what we do, we mix our signal with the carrier frequency and we frequency modulate it. Means what? We modulate the frequency of carrier signal according to the modulating inputs. जो भी आपका input amplitude रहेगा, क्योंकि it is nothing but a sine wave. So what is going to vary? Your amplitudes are going to be varied. So according to varying amplitudes, your data is to be carried out. Okay, so what we do, we modulate the frequency, we vary the frequency of carrier signal according to the input signal, which is called as the modulating signal. Okay, the definition is clear to you how the FM is done. Then next is, you see how it is done by looking at the picture. This is nothing but frequency modulation. एक simple सी sine wave दिखाई है. This is nothing but your input signal. Okay, and the second wave which you can see over here, this is nothing but a carrier signal. What is a carrier? Carrier is the frequency which carries our data to a particular place in air. Okay, so this is the carrier, means the high frequency signal. Okay, so this high frequency carrier is to be mixed with the input signal, modulating signal. But how it is to be mixed? we have to vary the frequency of carrier signal according to the incoming amplitudes of the modulating signal. So here you can see that this amplitude is varying from positive to negative. This is the highest peak. Okay, this is the highest amplitude, and this one is considered as the lowest amplitude. Okay, the negative one. So how we are modulating, just look at the FM modulated signal. Here the frequency till this point is constant. Okay, and now the frequency started to be varied. It is becoming, as soon as your amplitudes are goes on changing, according to this the frequency of your carrier signal is changing. Here you can see the frequency is changing, and here it becomes the lowest one. Here it is maximum, because this is the maximum of your input signal. Okay, so here the output frequency should be maximum. So here the frequency is maximum, and here the minimum is there. So you can see that this carrier frequency is having minimum frequency over at this place. So this is called as, what is, frequency modulated wave. Is it clear to you? एक बार फिर से बताती हूँ, हिंदी में सुन लो. This is the modulating signal. Okay, modulating signal means जो भी आपका input data है, आपकी voice से, आपका voice है से कोई picture है या voice plus picture वाला signal है, तो हम लोग क्या करेंगे, एक सेकेंड. What is this? This is the input frequency, means this is modulating signal, and then this is high frequency carrier signal. So how in frequency modulation we do, we vary the frequency of this carrier according to the amplitudes of this modulating signal. So here if the amplitude is maximum, so you will have the maximum carrier frequency over at this place, okay, and here is we are having very low amplitude, means it is in minus, so you are having a minimum frequency. So this is how we are varying the signal, we are modulating the signal according to what, according to the input sine wave. So what is modulation index? We have also seen modulation index in amplitude modulation. Okay, sorry, modulation index, here it is defined as frequency deviation delta to the modulating frequency. Okay, amplitude modulation में क्या हो रहा था, we were changing the amplitudes of the carrier frequency. Here what we are doing, we are changing the frequency of the carrier. So the deviation is important. Frequency deviation means what is the original frequency and at what extent we are deviating. Is it okay? So this is defined as frequency deviation divided by modulating frequency. Okay, so Fm should be greater than 1. This is the criteria for having a good frequency modulation. Here it decides, means the modulation index decides also the bandwidth and also the number of sidebands in FM wave. We have seen what are sidebands. Whenever we are going to modulate the signal, we are having the sidebands also. So here also we are going to see how the sidebands are there in frequency modulation. So the next slide we will see what is deviation ratio. Okay, we have seen this is the new term for us, deviation. So what is deviation ratio? We are also going to calculate. This is defined as maximum deviation divided by maximum modulating frequency. Is it okay? This term is very important whenever we are frequency modulating the signal. This is the next thing we can define in percentage also. जैसे हमने percentage modulation देखा था, likewise here it is percentage modulation index. So it is actual deviation divided by maximum allowable deviation. And the next thing is mathematical representation of FM. Like we have also seen in amplitude modulation, how does frequency spectrum looks like. So here also we are going to represent frequency modulation in terms of modulating signal spectrum. So how this looks like, this is nothing but the original signal. This is only the modulating signal. Okay, इसका equation देख लो हम कैसे लिख सकते हैं. Em is equal to Em cos of omega mt. So here the terms are instantaneous amplitude. Okay, then omega m is nothing but the angular velocity, which is also equal to twice pi fm. This is modulating frequency. FM is modulating frequency. Is it okay? So this is modulating signal, and then we have the carrier signal. एक एक का बताया है यहाँ पे. देखो carrier signal का equation हम कैसे लिख सकते हैं. This is nothing but a single higher frequency. So उसको हमने कैसे define किया. EC is equal to EC sine of omega CT plus phi. Here phi is also there because it is phase angle. Whenever we are changing the frequency, okay, whenever we are frequency modulating the signal, two things must be constant throughout. That is the amplitude, and the second one is phase. Whenever we are frequency modulating the signal, its amplitude and phase, means the angle, it should be constant throughout. Only the frequency has to be varied. So these are the terms related to carrier signal. Then we have FM wave, frequency modulated wave. How we mathematically represent it? This is the modulated wave. Okay, तो यहाँ पर देखो क्या क्या चीजें हैं. F is equal to FC 1 plus K. This is proportionality constant. Okay, this is EM cos of omega mt. I have also told you to keep a copy and pen with you, so that you can write these terms. Okay, just by looking at the presentation, you are not going to understand the things. You have to do the derivations also, and these derivations has to be written in the answer. Whenever the frequency modulation is asked, you have to derive the terms also. So you have to remember this. So just try to write it down. So this is the frequency modulated wave. अभी इसका presentation कैसे है वो हम देखते हैं. So here deviation is defined as K of EMFC. What is EM? This is amplitude of modulating signal, and FC is carrier frequency. So this can also be written as instantaneous amplitude. How we can write this? Frequency modulated signal का instantaneous amplitude है ये. देखो इसको हमने कैसे लिखा. A of sine F omega C comma omega M. So this can be written as A of sine theta. Okay, now we have to derive what is theta. This term, you put the constant value of this and you derive the value of theta. So this is nothing but omega dt. Now what is omega dt? You put the value of omega what we have got in the upper equation. So we have put it this in this equation. So after this, deriving this, you will get what is the output equation as omega ct plus delta sine of omega mt divided by fm, since delta is equal to k of em into fc. This already we have derived. Delta we have already derived. So उसकी value जब आपने put कर दी, so what we will get as, this is omega ct plus del sine of omega mt divided by fm. If we substitute this value in equation number 7, so what we get? The frequency modulated waveform equation. So this is called as A sine of omega ct del sine of omega mt divided by fm. तो इसकी जगह पे हमने क्या लिखा? This is nothing but mf sine of omega mt. So final equation, you just look at the final equation. This is A sine of omega ct plus m f into sine of omega mt. Okay, because this is having carrier frequency plus the amplitude which is decided deciding the modulating frequency instantaneous. Okay, so this is the equation of frequency modulation. Now the spectrum is nothing but amplitude versus frequency. Okay, what we do in frequency modulation, we are instantaneously changing the frequencies. So what will happen, we are having the number of frequency bands. जैसे आपकी frequency है, if you are having a carrier frequency of say 50 kilohertz, if you have 50 kilohertz carrier frequency and you have 2 kilohertz your input signal modulating frequency. So how you are going to modulate according to the input amplitude? You are going to divide 50 kilohertz frequency in terms of 10 kilohertz, 20 kilohertz, 30 kilohertz, 50 kilohertz. These will be known as the sidebands. Okay, so frequency spectrum will consist of the number of sidebands. That is also called as Bessel's function. See here, instantaneously the frequency is changing, constantly. As soon as the amplitude changes, the frequency of modulated wave will also change. Okay, so these are how we will have the sideband concept. You all know, we have also seen in amplitude modulation. So what does the frequency spectrum of frequency modulation says? That it has carrier. That is the first term in equation. जो हमने equation देखा उसमें दो चीजें हैं, पहले तो carrier है and the second one is infinite number of side bands. All terms except the first term are साइड बैंड्स. ओके, साइड बैंड एक फ्रीक्वेंसी पर्टिकुलरली जो कैरियर फ्रीक्वेंसी है उसको छोड़ के बाकी जो भी फ्रीक्वेंसीज अराइज हो रही है, दे आर कॉल्ड एज द साइड बैंड्स. ओके, here the amplitudes are given. You can have omega c is equal to twice pi fc and omega m is equal to twice pi fm. Means what? This is the carrier frequency and this is the modulating frequency. So this is the omega for carrier and this is for modulating frequency. So what will happen at the end in frequency spectrum? This is the final picturization of what happens in frequency modulation. Okay, just look at this picture. The modulation will be very clear to you by seeing this picture. So this is the center frequency. Okay, FC कैरियर फ्रीक्वेंसी है, जो हमने ओरिजिनल फ्रीक्वेंसी ली है कैरियर फ्रीक्वेंसी बोल के 15 किलोहर्ट्ज हाई फ्रीक्वेंसी जो हम ले रहे. ओके, सो दिस इज FC. Now we will have all these frequencies which arises according to the change in amplitudes. They are called as the side bands. So how the side bands are there? This is FC, so this is FC minus FM. This is FC minus 2 FM. This is FC minus 3 FM and FC minus 4, FC minus 5 FM. वैसे ही यहाँ पर FC plus FM, FC plus twice FM, FC plus thrice FM, 4 FM and 5 FM. So this is how all these frequencies, they equally unite to make what is called as the bandwidth, and it is denoted as infinity. Infinite number of side bands. So this is called as these frequencies, they are called as lower side bands, and FC plus FM frequencies, they are called as upper side band, and these are what? Amplitudes. Okay, so the frequency is changing according to the input sine wave. देखो पिक्चर वही है, आपका इनपुट सिग्नल वही है, कैरियर सिर्फ उसको कैरी करने का काम कर रहा है. इन टर्म्स ऑफ फ्रीक्वेंसी वो आपका जो ओरिजिनल सिग्नल है उसको कैरी कर रहा है. इज इट ओके? फ्रीक्वेंसी मॉड्यूलेशन. Now what we are going to see is the bandwidth of frequency modulation. So it is defined as twice FM into number of significant side bands. Means the frequency bandwidth of the frequency modulated signal, it is defined by number of side bands. Okay, so how we will define this? how we are going to calculate this? Here we are having effect of modulation index on the sidebands. Modulation index, you all know, it can be 0.5, 1, 2, 2.5 and 4. Here the significant number of sidebands on either side, you can have 2, 3, 4, 5 and 7. Okay, so here some examples are given. See here, FM modulation index, it is equal to 0.5. Here modulation index, it is 1. Here it is 2. So what happens when the modulation index is 0.5? It is having carrier frequency and it is having two sidebands, two upper sidebands and two lower sideband. If the FM modulation index is equal to 1, so it is having three sidebands, means three sidebands as USB and three sidebands as LSB. Here if it is 2, it is having four sidebands, means lower sidebands and four upper sidebands. So like this you will have to define the FM picturing according to the sideband pictures. Here according to the modulation index, what we have picturization है वो उसका. Okay, you have to define the sidebands, how it varies according to the input signal. Then what is the types of frequency modulation? Frequency modulation is also divided in two types. It is narrow band FM and wide band FM, NBFM and WBFM. This happens, narrow band frequency modulation happens when modulation index is small, and this WBFM happens when modulation index is large. Is it okay? So here some parameters are given and we have compared NBFM, narrow band FM, with wide band FM frequency modulation. Here modulation index is slightly greater than 1. Here it is greater than 1 itself. Maximum deviation, it is 5 kilohertz. If narrow band FM is there, the deviation of frequency means how many sidebands are there, that is defined by deviation. So it is only 5 kilohertz. But if wide band FM is there, it is 75 kilohertz. Okay, so here just I'm giving one example to you that narrow band FM happens when you have the simple voice signal. Okay, and WBFM when you have voice signal and when you have picture signal also, you need a lot of bandwidth. Here you will have wide band FM. So here bandwidth for NBFM, it is small and it is denoted as twice of FM. Here also it is twice of FM, but it is denoted as, it is larger, about 15 times greater than that of NBFM. Means it is largely 15 times larger than NBFM bandwidth. Okay. And the application of NBFM, it is in FM mobile communication, like you have wireless communications of police, you have ambulance, short range ship or shore communication, etc. When you have ships on water, which when it is floating, there also you need some communication from Earth station. Okay, because if the weather is not okay, we will have to communicate with the sailor. So what we do there also, we establish a one communication system, and there we can have frequency modulation. Okay, so in that frequency modulation we can have NBFM. Okay, and then here it is entertainment broadcasting, example of WBFM, it is entertainment broadcasting, or when high quality music transmission is there we need a larger bandwidth. So frequency modulation, which type of frequency modulation we are going to use? We are going to use wide band FM. And this is the next representation of frequency modulation. How we represent? in amplitude modulation also we have seen ki in two domains we can represent the modulation. So in which two domains we can represent the modulation? It is in time domain and it is in frequency domain. So how we define the waveform which we draw according to the varying amplitude, that is called as frequency modulation in time domain, and the sideband picture what we draw according to the carrier frequency, that is called as frequency modulation in frequency domain. Is it okay? Two domains are okay with you? How we are going to picturize this? This is in frequency domain and this is in, sorry, this is in time domain, because here the frequency is varying according to the time. With time the frequency is varying. Here what we have, frequency is varying according to the center frequency. Okay, according to the carrier frequency we are going to decide the lower side bands and upper side bands. Is it okay with you? So this is the representation of frequency modulation in two domains. So this is all with what is frequency modulation. We'll just repeat the presentation once again for you. We'll have a short. From here we have started that what is frequency modulation. We have frequency modulation as one of the type that comes under angle modulation. So angle modulation has two types, that is frequency modulation and phase modulation. In today's class we have seen what is frequency modulation. So what is frequency modulation? Here when we vary the frequency of carrier signal according to the input amplitudes of the modulating signal, that is called as frequency modulation, by keeping the amplitude and phase of the carrier signal constant. Okay, so this is how we do frequency modulation. Then this is the picture or waveform of frequency modulation. Then this is modulation index. It is defined as frequency deviation divided by modulating frequency. And then we have deviation ratio also. Then we have percentage modulation index. So it is defined as actual deviation divided by maximum allowable deviation. Okay. Then mathematical representation in FM. First, we have defined mathematically modulating signal. Then we have defined mathematically what is carrier signal. And then finally, we have tried to derive the equation for frequency modulated wave. So here what happens in frequency modulated wave is ki the amplitude and the phase of the signal, that is the carrier signal, is constant throughout. And what is changing? The frequency is changing with each amplitude, with each instantaneous amplitude, the frequency is changing. So what we will have? We will have number of side bands in frequency modulation, and which is defined by or which are given by basis function. So each sideband equation, it is defined here. This equation is giving you nothing but the sideband equation for the instantaneous amplitudes of modulating signal. So here frequency spectrum, in frequency spectrum what we have, center frequency, that is carrier frequency, and infinite number of sidebands. Okay, so here how we represent this, these sidebands in terms of fc is fc plus fm for upper sidebands and fc minus fm for lower sideband, and this total is called as the bandwidth for the frequency modulation. Okay, then next is what we have bandwidth for frequency modulation. This is defined as 2 FM into number of significant side bands. Like कि आपके side bands बढ़ गए तो bandwidth क्या हो जाएगी, bandwidth will also increase with the side bands. Then you have next, here we have given pictures of what happens when the modulation index changes, and according to this modulation index how the side bands are changing. So this with 0.5, 1, 2, 2.5 and 4, these are increasing modulation index. So what happens with the modulation index increasing, the number of side bands also increase. And if you have number of side bands as 5, so you have 5 at lower side bands and 5 as upper side bands. Okay. So here in frequency modulation also we are having two types, narrow band FM and wide band FM. The name itself suggests that in narrow bands we are having the less maximum deviation, और जो आपका modulation index है it is slightly greater than 1, but in WBFM it is more than 1, and also the maximum deviation is near about 75 kilohertz for WBFM. And the applications is also given to you, some of the applications that in FM communication we use NBFM, and in entertainment broadcasting we use WBFM. This is two types of representation of frequency modulation, in time domain and in frequency domain. So how we define or how we plot the signal in time domain, you just have to vary the frequency here according to the incoming amplitudes, and here in this representation keep the center frequency, that is carrier frequency, as constant, FC plus FM, FC plus twice FM and FC plus thrice FM as upper side bands, and FC minus FM as lower side bands. So these are the two types of representations, and this is all for this today's frequency modulation. So what we will have in today's class is what is frequency modulation. I'll just take your attendance once again.